What if a black hole shot past Earth at the speed of light? What if a black hole, that incredibly dense and mysterious region in space, suddenly began traveling past Earth at the speed of light, a velocity that nothing else in our universe can ever achieve? It's a truly mind-bending thought experiment, and exploring the potential consequences of such a scenario could reveal some truly astonishing and terrifying realities about the nature of space-time itself. Let's consider the fundamental properties of a black hole, starting with their immense gravitational pull, which is generated by a colossal amount of mass compressed into an extraordinarily small volume. These regions of space-time are defined by an event horizon, a boundary beyond which nothing, not even light, can escape the black hole's relentless gravitational grip. Now, imagine a black hole, not just passively sitting in space, but actively moving past Earth at the speed of light, a velocity that represents the absolute maximum speed allowed within the framework of Einstein's theory of relativity. The implications of this movement would be drastically different from what we might initially assume, leading to a cascade of effects that would reshape our planet in unimaginable ways. Firstly, let's acknowledge that the speed of light is a universal constant, representing the fastest that information and energy can travel throughout the universe, a cornerstone of our understanding of physics. As a black hole accelerates towards Earth at this unimaginable speed, the fabric of space-time itself would be dramatically distorted by its immense gravitational field, and it would create an increasingly powerful warping effect. Think about it like this. Imagine placing a heavy bowling ball on a stretched rubber sheet. It creates a dip, and anything rolling nearby will curve towards it. That's a simplified analogy for how massive objects warp spacetime. However, with a black hole moving at the speed of light, this warping effect would be amplified to an absolutely catastrophic degree, far exceeding anything we've ever observed or conceived of. The tidal forces, the differences in gravitational pull experienced by different parts of an object, would become exponentially stronger as the black hole approaches Earth, stretching everything out into incredibly long, thin strands, a process often referred to as spaghettification. Imagine a human being. Their feet, being closer to the black hole, would experience a vastly greater gravitational pull than their head, causing them to be stretched lengthwise like a noodle before ultimately being torn apart at the atomic level. As the black hole rushes past, the intense gravitational field would begin to strip away the Earth's atmosphere, pulling it towards the black hole with incredible force, and this atmospheric removal would initiate a rapid and catastrophic cooling of the planet's surface. The planet's surface temperature would plummet dramatically as the heat radiated away by the atmosphere, essentially freezing everything solid in a matter of moments, and the oceans would begin to boil away due to the increased vacuum and solar radiation exposure. Furthermore, the black hole's passage would generate incredibly powerful gravitational waves, ripples in space-time itself, that would propagate outwards at the speed of light, carrying with them immense amounts of energy. These gravitational waves, if detected, would be unlike anything we've ever encountered, representing a truly bizarre and extreme manifestation of gravitational interaction. The energy released during this encounter would be staggering, converting a significant portion of Earth's mass into energy according to Einstein's famous equation, E=mc², highlighting the profound connection between mass and energy. Now let's consider the implications for the structure of matter itself. As the black hole approaches, it would interact with the atoms and molecules that make up Earth, fundamentally altering their properties. That the intense gravitational field would compress atoms, increasing their density to unimaginable levels, and the black hole would effectively tear apart the very building blocks of matter, leaving behind a distorted and unrecognizable void. It's a scenario that challenges our fundamental understanding of reality, pushing the boundaries of what we consider possible within the universe. Scientists have theorized about such interactions, although the precise outcome remains highly speculative due to the extreme conditions involved. However, the theoretical framework of general relativity suggests that such an event would generate a complex web of gravitational effects, fundamentally altering the structure of space-time around Earth. It's important to remember that black holes aren't simply cosmic vacuum cleaners. They're incredibly complex objects governed by the laws of physics, and their behavior is influenced by a multitude of factors. The distance between the black hole and Earth would play a crucial role in determining the severity of the effects, as the gravitational pull would decrease with distance, but the interaction would still be profoundly disruptive. This hypothetical scenario compels us to contemplate the delicate balance of forces within the universe and the profound consequences that can arise when these forces interact in extreme ways. Ultimately, imagining a black hole traveling at the speed of light forces us to confront the deepest mysteries of space and time, raising questions about the nature of reality itself. It's a reminder that our understanding of the universe is constantly evolving, and that there are still countless phenomena waiting to be discovered and understood. Perhaps exploring these extreme thought experiments can help us develop a more complete and nuanced picture of the cosmos and our place within it, leading us to even more profound insights. Considering the scale of such an event truly demonstrates the astonishing power and complexity inherent in the fabric of space-time and the truly remarkable nature of our universe.